All right, so we've got a shorter lesson today on derivative graphs. This is going to be really similar to what we learned a couple of weeks ago, but we're just looking at a couple of different details here today. So this is really similar to our color-coded version that we did a few weeks ago. So if you want to color code this one, you can too. But you don't have to. But you can. If you want.
After lunch?
Is there like a pile of them back there? All right, so what we're seeing here is what we would expect to be seeing. If f of x is increasing, then f prime of x is positive. And if f of x is decreasing, then f prime of x is negative. And actually, those arrows could go both ways there. That's an if and only if situation. And we already had a pretty set of color-coded notes to go with this. So it's just repeat information. This part is. We can see on the derivative graph, so the derivative row is the bottom row, and this is the functions up there. You know, wherever the derivative crosses the x-axis, we have some sort of extrema in the function. Okay, so just another version of it if you want to keep that in your notes separately, you can. What I actually just want to highlight on this chart is these last three rows right here. And I want you to turn to your neighbor. What's so special about those rows, or what's weird about those rows, or why did I highlight them? Talk about it. All right. So, you guys are talking about it. What do we normally use to find concavity and points of inflection?
F double prime.
Yeah, we normally use f double prime. But as we saw on the warm-up, we can tell all of these things from looking at a graph of f prime of x. Now, if we had a function like an equation, we wouldn't be able to just know where f prime is increasing or decreasing. We would have to take the second derivative and do a number line test, right? But if we're looking at a graph of f prime can tell us everything that we need to know. And here's something that's important. Here's why we talk about this. FRQs usually, if they're going to give us a graph, they give us the graph of f prime. Now, there's not a graph for every question. There's like charts and words and equations and all kinds of things. But if you're looking at a graph, it's usually the first derivative. So when we're doing an FRQ, or if we're doing some like a quiz or a test for us, that where it says justify, if you are given f prime of x, talk about f prime of x. I guess when you justify. Let's put that there. This will make more sense when we do an example in just a sec. So this is just a good rule for free response questions. If you're given f prime of x, make sure f prime of x is your justification. Or in general, whatever information you are given, use that to justify. Don't use that to then prove something else, which then proves what you're supposed to justify. You can always do it with the given information. That's probably true. There's a picture version of this on the back if you want to have that as a nice reference. That's good. But what we're actually going to do right now is you guys are going to do the FRQ that was on the back of the multiple choice. This is an easy FRQ, but you guys are going to do it individually for 5 minutes, and then we're going to go over it. This is, yes, this graph is f prime of x. So like I said, most of the time, if we're given a graph, it's going to be f prime. So that means in all of our justifications, we should talk about what? F prime. F prime should be our reason for all of these. So every answer is going to look like this. It's going to answer the question specifically saying f has whatever it is, a horizontal tangent, relative max, concave down, at whatever location the answer is, and then because f prime something something. Okay? So they're all going to be structured like this. This is how we have to answer. So f has horizontal tangents at x equals what? -7? Yep. Okay, because f prime of x equals 0. That's all we got to say. But we need to talk about f prime of x specifically. Both f and f prime are called by name. We're specifying at x equals wherever. There we go. F has a relative max at x equals -1 and 8. Because f prime of x goes from positive to negative. Changes from positive to negative. Goes from positive to negative.
You don't have to mention it equals 0.
We don't have to because
Already
we
did.
yeah we already did in part
Do
A.
we need to write the because part, the reason why?
Yes, that's the justify. Yep. Okay. Letter C. F is concave down on what interval?
From -3 to 2, and then from 6 to
6 to infinity?
or 6 to 10.
6 to 10. Okay. Yeah. Because yeah, the domain is only -10 to 10. Okay, sorry, wait. Because why is it concave down there? Because f prime of x? Yes. And you don't have to specify, like, we don't have to say anything like at that location or on those intervals or at that x value, whatever, because we've already identified them. But yeah, so that's all we need to say. So we don't want to say something like because f double prime is negative. We don't see f double prime. We don't have a picture of f double prime. We have a picture of f prime. Now, is it true to say f prime of x is decreasing, therefore f double prime is less than 0, therefore f is concave down? Is that true? Yes. It's extra writing, though, and that's okay. You can do that. But we have enough information already with f prime. So just talk about f prime.
Is it fine if we say the other way around? Like we say f prime of x decreases, and then therefore f of x is
Yeah.
concave down. Because I had that down.
Yeah, that's fine. Yep. Any other questions?